All right, here we go. Conditional probability formulas. All right, this is where it gets a little trickier because depending on how it's worded, that's what you have to write down. So suppose the probability of rain tomorrow is, or probability of rain Saturday is 40%. What's the probability that you will clean the garage on Saturday? Well, the first one is if it rains. And let me change my color of pen here to something other than blue. We'll go green. So the first, oh, you still can't read that. Oh, hot pink. Okay. So this is rain and this is not rain. So rain is, there's a 40% chance of rain. So what's the chance that it will not rain? 60% chance. So there's a 90% chance you'll clean the garage if it rains. Well, there's a 40% chance of it raining. So the chance of you cleaning the garage if it rains is a 36% chance. Okay? There's a 50% chance you'll clean the garage if it doesn't rain, and there's a 60% chance it'll rain. 50 times 60 is a 30% chance. So if you add these two up, there's a 66% chance you'll clean the garage this weekend. A 66% chance that you'll clean the garage this weekend. Because there's a 36% chance if it does rain, and a 30% chance if it doesn't rain. And the chances of rains are listed. So it can be a little bit complicated when we have multiple layers involved. Okay? So in the previous lesson, you found the probabilities for frequency tables. In the example, the relative frequency table at the right, the probability for a sales representative to have an increase of sales, given that he attended a training seminar, was 48% of the 80%. Okay? Because 80% of the people went to the training seminar, 48% out of all the people had increased sales. So you took 0.48 out of 0.8, which is 0.6 or 60% of the people. If 60% of the people that went to the seminar had a chance of increased sales or probability of increased sales. Okay? So let's look at these pharmaceuticals. In a study designed to test the effectiveness of a new drug, half the volunteers received the drug, the other half received the placebo. So we have the drug is half the people, the placebo is half the people. Okay? If the probability of volunteer who received the drug getting well was 45%. What's the probability of someone getting well given he receives the drug? So 45% of all the people that were in the study got better if they received the drug. 45% of the 50%. So you have to take 45% of the 50% because 50% people received the drug. So 45% of 50% is 90% of the people who received the drug got better. Now, 45% of the people in the study got better because they received the drug. But if you received the drug, 90%, you had a 90% chance of getting better. Okay? The probability of taking a placebo and having your health improve was 20%. So a 20% chance of getting better if you had the placebo out of the 50% of the people who were in the study. Well, 20 out of 50 is 40%. So you had a 40% chance of getting better if you were in the study receiving the placebo. Okay? So that's where it makes it a little more not super easy to understand. So let's look at the problems that you will be doing. All right. A jar contains so we have marbles here. 9 large red marbles, 3 small red marbles. So we have red marbles and blue marbles. We have large and then small. And then we have our totals. So we have 9 large red, 3 small red. 7 large blue, 4 small blue. The blues there's 11, the reds there's 12. The large there's 16, the smalls there's 7. How many total marbles are there? 23. So it's a chart kind of like our professors and teaching assistants chart. Okay? So now they want to know what's bigger. Given that you got a small marble, that the percentage of it is blue, or given that you got a blue marble, the percentage that it's small. Okay? So let's look at the probability of blue given that it was small. So you start with this one. Out of all the smalls, how many are blue? Out of all the smalls, there's 7 smalls. How many are blue? 4. So that's a 4 out of 7. Or change that into a decimal, please. Somebody take 4 divided by 7 on your calculator. 0.57. Okay. Now, let's look at the probability that it's small given that it's blue. Out of the blue ones, there's 11. How many small ones are there? 4. So it's a 4 out of 11 chance, which is like what? 0.36? Okay. So which is bigger? Given that it's blue, given that it's small, it's blue, or given that it's blue, it's small? Which one's bigger? Given that it's small, it's blue. So given that it's small, so given that it's blue, it's small. Oh, that's not right, because that's that one. We want this one. So given that it's blue, it's small is 4 out of 7. Given that it's small, it's blue is 4 out of 7. Given that it's blue, it's small is 4 out of 11. It says simplify your answers. Please leave them as fractions, simplified fractions. All right, a survey. Use the survey results to find the probability that the respondent has a pet, given that they have had a pet. They have had a pet, and 36% have now and have had a pet. So you take 0.36 divided by the 0.82, because it's 36% of the 82%. So somebody on your calculator, take 0.36 divided by 0.82 and round it to the nearest hundredth. Nearest hundredth is how many decimal points? 2. What do we get? All right. At a library, 20% of the library books are fiction. At a library, 30% of the books are fiction, 70% are nonfiction. Of the fiction, 20% are worn and need replacement, and that means 80% of those are good. Of the nonfiction, 20% are worn and need replacement. That means 80% of them are good. So if we multiply across, this is 6% of the books. This is 24% of the books. We multiply across 70 times 20. This is like 14% of the books. This is like 56% of the books. If you add all these numbers up, what do they add up to? 100%. They better bet up to 100% or something's wrong here. Okay, what's the probability a book chosen at random is worn and needs replacement? Well, this and this are both worn and need replacement. What's 6% plus 14%? 20% of them are worn and need replacement. In a research study, 1/3 of the people got drug A, 1/3 of the people got drug B, and 1/3 of the people got a placebo. Okay? Out of everybody getting better, 12% of the people that got better also received drug A. And they got better. So let's put a smiley face because they're happy they got better. Out of all the people that got better, 13% of them received drug B, and they got better. And then 10% of all the people that got better got the placebo. So we know that like 35% of the people got better. That means 65% of the people didn't really get better. Now, what's the probability of getting better if they were given the placebo? Well, given the placebo, out of everybody, 10% got better. But just given the placebo alone, 10% of the 33%, because 1/3 is 33%. So if you take 0.10 divided by 0.33, I think it's what, 30%? So 30%. See, this is a percent. So should you put 0.3 there? No, it's 30%. Okay. All right. So the second assignment, well, get that out and make sure you read to make sure you put the answers down correctly. And then if you're Dylan or Hunter, after a little bit, you guys can take the quiz that you missed. Yep.